Hi, I'm Terry Butchie from the Ohio State University Math Literacy Initiative. We've been taking these Monday math days, and trying to serve those of you who are at home with your children or grandchildren or siblings and now your teachers. So, yeah, you. And there are a lot of people who have some questions about particular things that their students are learning. So I'd just like to start by saying if you are working with your child or student and there's something that's just they're really not grabbing onto, or you want some help with it, please send us either a Facebook message or an Instagram message. And we'd be happy to spend some of our time on Mondays working on whatever concept it is that you're working on with your child. So our goal is to serve you and to help you help your students. And we know we need that right now because you're all at home, but it can benefit your students when they all go back to school too. So thanks for spending the time to learn a little bit more about the math that your child's going through. The last session we're going to do today is on multiplying decimals. Not everyone's favorite, but there are different ways that you can do this. So sometimes we think, we just have to tell them what to do and they're just going to have to memorize it. But sometimes there are ways that students can figure things out, even if you think it's a little bit like programmatic or automatic. So let's talk first about what multiplying decimals means, because whenever you talk about a topic, you have to first understand the meaning of it. So what does multiplication mean first? Let's look at a simpler problem. So what is 6 times 3? First of all, what does it mean? It means 6 groups of 3. So we have one group of 3 here, another group of 3, another group of 3, another group of 3, another group of 3, 1, 2, 3, 4, 5, 6 groups of 3. And then we find out what 6 groups of 3 is. So what do we have when we have six groups of 3? Well, we know that 6 groups of 3 gives us 18, right? We have 3, 6, 9, 12, 15, 18, counted by 3s. So you want your students to be able to be fluent with things like this first, knowing what multiplication means. So if 6 times 3 means 6 groups of 3, what would 6 times 3.4 be? It looks a lot like this one, but there's this extra added stuff. So what does it mean, and how do we use that to figure out what the answer is? So if 6 times 3 means 6 groups of 3, 6 times 3.4 means 6 groups of 3.4. Exact same thing. It's telling us the same operation. It just has different numbers. So what does that mean? Well, we have a 3.4, a 3.4, a 3.4, a 3.4, 1, 2, 3, 4, 5, oopsie-doodle, and 6. All right, so what do we have here? So we have 6 chunks of 3 over here, 6 chunks of 3, and we know that one is 18. We just did it up here. But then we have this extra stuff. I'm going to put my decimal here because I covered it up. We have this extra stuff. We have 6 groups of, I'm going to put a 0 there just so that you can see the decimal point. 6 groups of 0.4. 6 groups of 0.4. What does that mean? Well, we can add up all those 0.4s and figure out what that means. But I want to show you another way to think about it with your student. Now, there's nothing wrong with adding up all the 0.4s and finding out what you have. But let's look at this. One thing that we've talked about the mathematical practices, and mathematical practices or processes and practices are what mathematicians do. Like what is our role as a mathematician in this world? And so one of the things that we know that mathematicians do is they look for repeated reasoning. They look for patterns. not they, we, because we're all mathematicians, we look for patterns. We look for repeated reasoning. We look for things to jump out at us so we can make some declarations about them. So let's look at what kind of patterns we can find with multiplying decimals. So I'm going to start off with this. 4 problems. We have 4 problems here on multiplying decimals. The first 2 I've used as a whole number times a decimal number. So a whole plus a part and a whole, or excuse me, a whole times a part and a whole. And then down here later we have a part and a whole times a part and a whole. When I say part and whole, the whole part is the part that's in front of the decimal. The part of it, the smaller part, is this here. Now, decimals are fractions out of 10. That's basically what it is. So we have 2/10 there, but we're not going to talk about that as much right now. We're just going to talk about how we can get students to discover on their own what the rule is for multiplying decimals. So let's start. So what do we have? We have 6.2 times 5. So what is 6.2 times 5? Now let's think just for a little bit. What I want you to do when you work with your student, if you'd like to, is to first make a guess. What do you think it's going to be? So let's look at just the whole numbers. So we have 5 times 6. Yes, I know there's this 0.2 left over there, but I really just want whole times whole. And that'll give us an idea of what the answer should be. So 5 times 6 is 30. Now we know we have 5 of these 0.2s too that we just haven't counted yet, but we know that our answer is going to be somewhere around 30. So let's do our multiplication problem and see what we get. Now at this point we're in 5th grade and we've done multiplication by 1 digit, 2 digit, 3 digits numbers, and also 2 by 2 numbers. So we're not gonna talk right now about how to do the multiplication of it. The assumption is that your students have gotten there. So let's say we have 5 times 2 is 10. So 5 times 2 is 10. We have the 0, and then bring 6 is 30. That means our answer is going to be somewhere around 30. So if our answer is somewhere around 30, where could we put that decimal point? And right now we're just playing with these numbers. So if we want this 310 to be a number close to 30, because we know that that's where it's going to be, where would we put that decimal? Well, right here, there's the number 31. That's pretty darn close to 30. So I'm going to put that decimal point right there. And I'm just going to leave it alone right now. I'm not counting up spots behind the decimal, none of that stuff. We're just looking for patterns now. All right, so now let's try this next one. We have 4 times 7.25. 4 times 7.25. So now let's do what we did again here. So we have 4 and the whole number here is 7. So 4 times 7 is 28. So we know our answer is going to be somewhere around 28. So let's figure out what it is. Well, we have 4 times 5 is 20. I'm going to regroup my 2 up here. 4 times 2 is 8 plus 2, 9, 10. So I have my 0 and my regrouped 1 up here. 4 times 7 is 28 plus 1 is 29. So I got the answer 2900 or 2,900. Well, we figured when we started our problem that it's going to be pretty darn close to 28. Well, 2,900 is not close to 28. That's a pretty big number. But there is part of this number that is pretty darn close to 28, and that would be 29. So if we put the decimal point right here, we could have a number that's very close to 28, and we know what where that decimal has to go just because of sense making. So now let's do the next one, because the next one's going to be a little bit harder. You should never say something's going to be hard to your child, because if you say something's going to be hard to your child, then they already have this like thing in their head. They're like, I'm just not going to get it. Or if you say, oh my gosh, I hated this, please don't say that to your child, because all they do is they're like, okay, well, they hated it, so I'm going to hate it too. Don't do that to your child, please, 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 please. So this one, let's look at this one. So we have whole and part and a whole and a part, because we have two numbers that have decimals in them. So we're going to say 3.2 times 5.6. So now let's do what we've done before. So let's just look at the whole numbers and get a number. So we have 3 times 5. So 3 times 5 is 15. So we know our answer is going to be somewhere around 15. So now let's just do our regular multiplication. This is a multiplication algorithm, which by 5th grade, they should be working on they should have a handle on the multiplication algorithm. So 6 times 2 is 12. 6 times 3 is 18, plus our 1 that we regrouped over here is 19. We know that 0 is there. If you don't know why that 0 is there, please look at my YouTube on multiplying multi-digit numbers, and that'll let you know where that 0 comes from. 5 times 2 is 10, so I have 0, and I'm going to put my regrouped 1 over there. 5 times 3 is 15, plus that 1 that I regrouped, so that's 16. And now we're going to add these 2, 9, 7, and 1. So now let's look at this. We have 1,792 with no decimals in there. But we know our answer should be close to 15. So if we wanted to put our decimal place someplace in this number, where would we put it? So we have a number that's kind of close to 15. Well, if we look at just this part, 17 is pretty darn close to 15. So I'm going to put my decimal point right there. Again, I haven't done any counting, decimal points, nothing. We're just making sense of these. So now let's do this last one. So we have 6.8 times 4.3, and 8 times 3 is 24. I'm going to regroup my 2. 3 times 6 is 18, plus those 2 that I have regrouped. That gives us a 20. And I'm going to cross off this 2. I should have done that over here, but just so we don't get mixed up on our 4. So remember, we have our 0. Again, check out the YouTube on multiplying multi-digit numbers. 4 times 8 is 32. So now I have this 3 here. And 4 times 6 is 24. Plus we have to add on our regrouped 3. So 24 plus 3 is 27. So now we have 4, 2, 9, and 2. Oh, we didn't do our check. We didn't do our what do you think it's going to be close to yet. So let's do that, because that'll help us to know where that decimal point should go. So if we look up here, we have a 6 whole number and we have a 4 whole number. So 6 groups of 4 is 24. So we know that this number that we get on our multiplication has to be somewhere close to 24. So if we look at this, somewhere close to 24 would probably be that 29 right there. So this is one way that your students can multiply decimals and just kind of play with the number. So we're just guesstimating right now where that decimal point should go. What I suggest you do with your student or your child at home is many of these. So don't do many in one day, because it's just not. Just do like 5 or 6 or something, and then do it for a few days in a row, and then keep all of the work. So now we look at this, and let's say we did this for 3 or 4 days. We have 4 problems. And you want to also start introducing numbers that have 3 numbers beyond the decimal point and maybe like 1 beyond here. So you want to mix it up a little. But then what you do is you ask your child to look at, so this, let's say we have 12 of these that they're looking at so far. And again, remember, you have not told them that counting the number of digits beyond the decimal point thing yet. We haven't talked about that. So we just have all of these. And then you ask your child, well, what do you notice? What do you notice about these problems? If you looked at just the problem and then just the answer, so let's circle those there. So just the problem and just the answer. So we have this and this, this and this, this and this, and this, and this. Let's see what we notice. And you've got to be patient. So don't jump in. Just let them see what they notice. And whatever they notice, you write it down. It's brainstorming. That's their voice, their mathematics. So honor it and write it down. But what you, of course, want to get to is the point where they see, okay, is there any relationship between the number of digits behind that decimal point and the number of digits behind the decimal point in the problem? Now, you don't want to ask that question too early because it's pretty much a guided question and tells them the answer. But if they're not recognizing it, and that means within minutes, like you give them 5-10 minutes to write down everything they notice. So don't kind of guide them to it unless you think they need it. But if we look at this and we look at this, what do we notice? Well, look at that. There's 2 numbers behind the decimal point there in the problem and 2 numbers behind the decimal point there. So one guess could be the number of digits behind the decimal point in the problem is the same as the number of digits behind the decimal point in the answer. Now, we could have absolutely just straight up told your student that. It's not as powerful when you do that. You're saying, here's the math I know. I want you to know the math I know. And here it is. Well, that doesn't have a lot of power with your students or your children. So you want them to figure it out. You want them to say to you, well, duh, mom or dad or brother or sister, there's 2 numbers behind the digits in the problem, and there's 2 here. So, and then there's 2 here, there's 2 here, there's 1 here, there's 1 here. Now notice that some of these I have 2 within 1 number and some just a single one back there. You want to kind of mix the problems up. But basically what you're doing is you're providing your students enough problems so that they can start to see a pattern emerging. And that pattern that emerges is the rule that we use for multiplying decimals, which is in the content of the problem, you count the number of digits behind the decimal point, and that's how many you have to have in the answer. Now, if you just come straight out and say that, that's just another thing that they have to memorize. But when they discover it, it will stay learned because they're the ones who told us that rule, and they own it. And once they own it, they can use it, and that's our goal. So, any questions that you might have about this or extensions that you might be interested in learning about, please send us some comments either on Facebook or our Instagram page, and we'd be happy to cover some of those questions for you. So have a fabulous week. It's nice and sunny out here in Ohio. I hope it's sunny where you are, and if it's not, I hope you have a sunny place in your mind that you can go to and sit in the warmth. Thanks for being with me. I'll talk to you hopefully next week. Monday Math Day, next Monday. Have a great day.